Okay, so today we're talking about isosceles and equilateral triangles. What's an isosceles triangle?
Two same sides.
Two sides are the same? Now, could I say a triangle that has three sides the same is also isosceles?
No, it's equilateral.
It's equilateral. So three sides the same, two sides the same. Got it? All right. So if I have an isosceles triangle, I just want to get some names down. This is called the vertex angle. All right, so if we have an isosceles triangle, the base angles are congruent. Write it down. If we have an isosceles triangle, the base angles are congruent. All right. Anybody know what the base angles are in an isosceles triangle? Or where the base angles are? Yes.
Are they the two angles on the bottom?
The two angles at the bottom are correct. Good job. So I'm going to put a marking here and here. All right. So let's label these. What are those called? Base angles. So if you have an isosceles triangle, base angles are congruent. And this here is called the base side. The base side, the base angles, the congruent sides, the vertex angle. Everybody see that? Base side, base angles, the two congruent sides, and the vertex angle. All right, so in this isosceles triangle, base angles are congruent. The converse is also true. What does a converse mean? We talked about that the first week of school. The opposite. So that's saying if I have a triangle where base angles are congruent, I can then say the triangle is what?
Isosceles.
Isosceles. Good. All right. I'm going to label this up here. This is a theorem. And we're going to go over another theorem. Which states, all right, let's stop the talking, please. I'm going to call this triangle A, B, C. Everybody have it? Okay, I'm going to write down some stuff here, and it's going to be quite a bit, so I suggest you write it down with me. If a line bisects the vertex angle of an isosceles triangle. If a line bisects the vertex angle of an isosceles triangle, where is my vertex angle? Let me put more markings down for you. If this is the isosceles triangle, where is my vertex angle? A, B, or C? C. The vertex angles, the two that are not the base. Where are my base angles in this picture? A and B, and AB is my base side. Do you guys see that? So, if I have a line bisecting the vertex angle, what does it mean to bisect? These two angles are equal, congruent, the same. Okay, so if a line bisects the vertex angle of an isosceles triangle, then the line, and that's this line that I just drew, is also the perpendicular bisector of the base. Go ahead and write that down. And what does that mean? These right here are right angles because it's perpendicular. And if it bisects the base, I'm going to call this D. What can I say about AD and BD? They are congruent. Make sense? All right. Questions on that theorem? All right, one more. What kind of triangle is that?
Equilateral.
And why is it equilateral?
Because all the sides are the same.
Everybody see that? 3 congruent sides, it is equilateral. All right. If a triangle is equilateral, then the triangle is if a triangle is equilateral, then the triangle is equiangular. Have you guys heard that before, equiangular?
No.
Some of you, yes, no. Any thoughts on what equiangular means? Yes.
The angles are equal.
That the angles are also equal. So could I put markings in here? Yes?
Yeah.
All right. So, as long as 3 sides are congruent, it doesn't matter how big or small the triangle is, what's going to happen with all 3 angles? They're going to be equal. What do they have to be? If the sum is 180, and these 3 are all the same, what are they all? 60. So it doesn't matter how big or small my triangle is. If it's equilateral, the angles will always be 60, 60, and 60. Yes?
Are those theorems called anything? Or?
Just theorems. Okay. And on this one as well, the converse is also true. Okay, so what does that mean? If I have a triangle that's equiangular, all the angles are equal, what can I assume about the sides? They're equilateral, they're all the same. All right, any questions before we move on to examples?
No.
All right. Find X is what we're going to be doing.
At least we can drink water.
All right, so you're going to have a triangle like this in your homework. Sometimes your X is an angle, sometimes your X is a side. Is this X a side or an angle? An angle. All right. If it's an angle, that means you know something about your side. So look in the outside. Is this an equilateral or an isosceles? Why is it isosceles? Because these 2 sides are congruent. If these 2 sides are congruent, what is your base side? The 3, the 7, or the 7? This is your base side, which means these 2 are your what angles? What are they called? So if it helps you, sometimes people will flip it like this, and you can see it Isosceles, base side, base angles. If these two are my base angles, what do we know about the two angles? They are equal, congruent. So what should I put here, an x or a 32? X. And then I'm going to make an equation. And yes, I do need to see these equations on your worksheet today. X plus 32 adds up to what? 180. X plus x is 2x plus 32 equals 180. Do we agree with that? Jordan, can you give me the next step? Subtract 32 from 180? It's okay. And that gives me 2x. Has anybody subtracted already?
148.
148? And Jordan, can you go and give me the last step?
You divide
By 2. And x equals 70 what? 4. All right. Any questions on that one? Does it make sense?
Yeah.
Okay. Next one. All right. Okay, so first thing you look at is where is x, an angle or on the side? An angle. If it's an angle, that means you know something about your triangle. It's either isosceles or equilateral. What is it? So what are my two congruent sides? 12 and 12. So what is my base side? 11. If this is my base side, then these two here are my base angles. Do you see that? If it helps you, flip it around. Isosceles triangle, 12, 12, the congruent sides, base side, base angles. Do you guys see that? Okay, so what do I put in this missing corner here, an x or a 67 if these two are the base angles? 67. Now you have to be careful because what was the missing angle in the last problem? We called it x. Is it always going to be x? No. Is it always going to be the other number? No, you have to look at the problem. So am I going to do x plus x or 67 plus 67? Plus 1x equals 180. Go ahead and solve that now. Anybody have it? 67 plus 67 is 134. And then what do we subtract from both sides?
134.
134. And that there is an equal sign. Sorry. And the answer is x equals 46. All right, questions before I move on? All right. Okay. Where is x? A side or an angle?
Angle.
An angle? Oh, sorry. An angle. Okay, so that means you know something about your triangle. It's isosceles or equilateral. Now, how do we know it's isosceles if I didn't give you any side lengths? Yes.
The 90 degrees, or yeah, that.
The tick marks.
The
two tick marks tells me it's isosceles. It is a right triangle, but it's an isosceles right triangle. Do you see that?
Yeah.
Okay, so these two are my congruent sides. Where is my base? Tell me when I'm pointing to the base. Is this the base?
No.
Is this the base? Is this the base?
Yeah.
Yes, this is the base side. What's another word for this in the right triangle? The hypotenuse.
Hypotenuse.
Hypotenuse. Okay, So again, if it helps you, then you'll be turning your paper around. Do you see the isosceles triangle? If this is the base side, these two sides are what? Base angles, which means they are the what? The same. So what do I put in this corner? The 90 or the x? The x. And so what's my formula? X plus 90 equals 180. Go ahead and do that now. Cole, can you tell me what the next step would be? Minus 90 from the 180. And have you done that step already? 2x equals 90. And then the next step? Both of them by 2. And did you do that step already? And what did you get?
X equals 45 degrees.
Perfect. All right. Any questions? Okay. Number 4. Number 4 is going to look a little different, and you need to be paying attention to this one because kids mess this one up every year. You're writing it down with me. Everybody have it? Okay, how is this one different from the last 3? Yes.
Well, there are no.
Louder?
There are no like congruent marks.
Okay, there's no congruent markings anywhere, so we don't know what kind of triangle it is. Good. What else? Look at the x's, the placing of the x's. Yes.
Yeah.
Not sure. The last 3, where was x?
Inside.
Inside it as an angle. And this one, x is
Outside.
outside. Does it make a difference? It does. Biggest mistake kids make on the test, they say this side plus that side is 180.
No.
Is that right? No. Do sides add up to 180?
No.
They can, but it's not like angles inside. They have to add up to 180. So please, please, please do not make that mistake on the test. Side plus side plus side is 180. All right. So since x is on the outside, that means we need to figure out what kind of triangle it is by looking on the inside. And I'm going to take a step back. You guys said earlier there were no congruent markings, correct? So since there's no congruent markings, that's why we need to go on the inside. They didn't give me this angle here, but do we have enough information to figure it out?
Yeah.
Yeah. Why? They add up to 180. Earlier we did not because we had x's on the inside, so we had to do some extra work. But this one, what are you going to do? Add these up and subtract from 180. Do that now.
I know this.
Okay, give it to me.
48 degrees.
48 degrees. Does everybody agree?
Sauce.
All right. Is it equilateral or isosceles? How can you tell? Because there's 2 congruent angles. In order for it to be equilateral, it would have to be equiangular. And this is not. Okay, what do we call these 2 48s? These are called the base angles, which means the base side is which one? Which one's the base side? This one here? Okay, if this is the base side, what 2 sides are congruent? 3x minus 4 and 2x plus 5. Was this x plus 7 a distractor? Or you're not going to use it at all. So why do they give it to you? To distract you. So you can figure out, like if I didn't give it to you, you're like, oh, those other 2 must be equal, and then you do the work. It's there, so you have to think, okay, let's find the angle. It's isosceles. Because these two are the base angles, that means this is the base side. Cross out the base side, and those two are your congruent sides. Does that make sense? All right, so what does your equation look like? 3x minus 4 equals 2x plus 5. We subtract the 2x. And what's 3x take away 2x? X minus 4. Did I hear somebody say add the 4 to the other side?
Yeah.
And what does x equal? Any questions? All right, last one I'm going to leave you to do while I hand out the packets. I'm handing out a new packet because we finished the last one. Are you doing the whole packet tonight?
Yes.
No, just the first worksheet. Okay.
Wait, when's our first test? This Friday?
Our quiz is tomorrow. Our test is next week. You can look on your orange paper. Yes.
Wait, what's the quiz on?
The quiz is on everything up to even today stuff, so everything up to today. I don't know. All right, guys, write this down. Sorry. So sorry. Okay. Shh. All right. Find x, find the perimeter, and blah, 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 blah. Working, you're not just sitting there. Do you guys have enough information to find the perimeter right now? Yes, how do you find the perimeter? Add up all the sides. Anybody tell me what it is? 19? Yes. 51. Yes, just hustle because the bell's about to ring in like a minute or two.
Oh, dang. No.
All right, did I miss anybody getting the packets out? Did I miss you guys?
Yeah.
Did I get you guys? Yes. If you did not get a packet, let me know. All right, we're getting through this quickly. What did you guys say the perimeter was? 19. What goes in here, the 51 or the X?
51.
Okay, these are my equal sides. Do you agree? This is the base. So what goes in here? X. So x plus 51 equals
180.
180. Did anybody do it all already? It comes out to be a decimal. 64.5. Good job. Oh, acute, obtuse, or right? Acute. Why? Because obtuse means you have an angle bigger than 90, or any of these angles bigger than 90. No, right means equal to 90, which they are not. Make sense?
Can I just label this on the booth?
Not yet. I'll tell you guys how we're going to turn our packets in tomorrow.